In this video, we're going to be finding the initial amount and rate of change given an exponential function. Okay, so recall that initial amount occurs at time equals 0, so t equals 0. That's at the beginning, so no time has passed. Okay, and also recall that initial and original mean the same thing. So when I say initial amount occurs, that's also original amount. Those two words can be used interchangeably in this section. Okay, same thing. All right, so we're going to use this, the initial amount or the original amount times 1 plus, could be minus as well. Should put a plus or minus depending on if it's growth or decay, and then the time, which would be t, is up top. All right, so first question. A study is done on the population of a certain fish species in a lake. Suppose the population size p of t after t years is given by the following exponential function. P of t is equal to 230 and then times 1.22 to the t. Okay, so I'm going to write this in another way to give us a little more information. Okay, the 230 I'm going to leave alone. Instead of writing 1.22 on the inside, I'm going to write 1. And how much am I adding to get the 0.22 on there? So here's the 1. I need 0.22 more. Okay, and then there's the t. So the reason I wrote it expanded out like that is because if you look here, that gives you your rate. Okay, so that gives you your rate, whether it's a growth or decay, this is still your rate. Okay, and we put that in terms of percent. So 0.22 would be 22%. So let's answer these questions. A, find the initial, which is also original, right? Original. Population size, okay? That's the number that's out in front of this thing. So that's 230. Okay, that was the initial population of fish. Okay. And then does the function represent growth or decay? Okay, so if this number inside is more than 1, it's growth. This is 1.22. That would mean it's growth because you have 100%. That's the 1 right there. And then you're adding this onto it. So it's more. So this is going to be growth. And the last question says, by what percent does it change? That's this number right here. 0.22 is the decimal way of representing 22%. Okay, so you move that decimal twice, boom, boom, and it becomes 22. And that's the answer for the third one. Okay, let's look at the next one. A study is done on the number of bacteria cells in a petri dish. Suppose the population size P of t after t hours is given by the following exponential function. Okay, so we've got this. I'm going to write this also in another way. Okay, just put a little arrow there. P of t is equal to, I'm going to leave the 2,300 out front. And then this time I'm going to write 1 minus a number to the t power. Okay, so how much did I have to subtract from 1 to get 0.82? Okay, so that would be 0.18. Okay, and if you want a little help on figuring that out, you can go to your calculator real quick and just do 1 minus 0.82 and see what it gives you. There we go, there's the 0.18. Okay, so now let's answer these questions. Initial or original population size, that's this number, 2,300. Does the function represent growth or decay? Is this number inside more than 1 or less than 1? Well, this time it's less than 1 because we're subtracting off some stuff, right? Okay, so that would mean it's decay. And then by what percent does the population size change each hour? Okay, so that's where this number comes in. And you don't care necessarily, you don't really care about the negative in this because it just says by what percent does it change. It doesn't care if it's positive or negative change. Okay, it is negative change because it's decay. That doesn't matter for us. So it's this number right here we're looking for, which is 0.18. If I move the decimal places over to turn it into a percent, boom, boom, it would be 18%. So the population of fish changes by 18% every hour. Last one. A can of soda is placed inside a cooler. As the soda cools, its temperature, C of t in degrees Celsius after t minutes is given by the following exponential function. Here it is. I'm going to write that in another way real quick. So here's the 23. That doesn't change. And then there's my t. So this is less than 1, right? Okay, so I need to do 1 minus something. And what do I need to subtract off to make it turn into a 0.88? And you can think of this also in terms of how do I change a 100 into an 88? What happens there? to make that happen? Well, you'd subtract 12, right? Okay, so but this is in terms of decimals. So instead of subtracting 12, you'd subtract 0.12. Okay, 1 minus 0.12 is 0.88, and you can confirm that in your calculator if needed. All right, let's answer the questions. Find the initial temperature. It's the number out front. That's 23 degrees Celsius. Okay. Does the function represent growth or decay? Is this number bigger than 1 or smaller than 1? It's smaller than 1. That is decay. By what percent does the temperature change each minute? That's going to be this number after we convert it to a percent. So move that over, boom, boom. That'll be 12%. Okay, and that's it.